Inverse variation means that as one variable increases, the other will do the opposite. It will decrease instead. So the way you see that translation is y varies inversely, or the words y is inversely proportional. If there's a non-zero constant, again, that constant of variation is there, k. But the variable itself will be under the fraction bar. Notice that y equals k over x is a rational function. We can see this relationship on the graph. This is what this equation looks like. So as y decreases, x increases. Or if you look at it the other way, if x decreases, y increases. So it's a inversely proportional or inverse variation relationship. So our third problem here, suppose that y varies inversely as x. If y is 6 when x is 3, find the constant of variation and the inverse variation equation. So these are the key words here. Varies inversely. So the variable before those words equals k over the next variable, x. That's a direct translation for varies inversely. So then they give me some numbers here so I can solve for k. Always your first goal with variation. So it says y is 6 when x is 3. Okay, so in order to solve for k, it's being divided by 3, so we need to do the opposite, the inverse function here, multiplication. So we'll multiply 3 to both sides. Then on the left side, 3 times 6 is 18, and on the right side, the 3 divided by 3 is 1, so that's just 1k, or k. That's our constant of variation, so that's the first part. And then we need the inverse variation equation. And that is exactly what we got from our translation, but put the k in. So y equals 18 over x is our inverse variation equation. And we could answer questions about that now, as we will in the next example. For 4, the speed r at which one needs to drive to travel a constant distance is inversely proportional to the time t. A fixed distance can be driven in 5 hours at a rate of 24 miles per hour. Find the rate needed to drive the same distance in 4 hours. So they gave me a variable here, the speed r at which one needs to drive to travel a constant distance. That's a lot of words. That means this is r. is inversely proportional. So there's our key words there to say equals k over time t. So that variable is given. Then we can solve for k with the next information. The fixed distance can be driven in 5 hours, so that's t, 5 hours, at a rate of 24 miles per hour. So this allows us to solve for k. If it's divided by 5, then we multiply 5 to both sides of the equation. 5 times 24 is 120, so k equals 120. And that will complete my inverse variation equation. The rate is 120 divided by the time. So then they ask me find the rate. So find r to drive the same distance in 4 hours. So that's t, the time. Well, 120 divided by 4 is 30. So the rate is measured in miles per hour. So that means that's going to be 30 miles per hour to drive the same distance in 4 hours. For 5, suppose that y varies inversely as the square of x. If y is 24 when x is 2, find the constant of variation and the variation equation. So keywords here are varies inversely. So the variable that comes before that equals k over the variable that comes after that. And this is a little tricky because it's not just x, it's the square of x, so be careful. Square means raised to the second power. If you see cube, that means raised to the third power. Square root means that. So just be careful if there's other words there that tell you to do something with that. So the square of x is x squared. So now we can solve for k given the next information here, which is if y is 24 when x is 2, and it's not just that, it's x squared, so 2 squared, right? So we can use that to solve, and we're going to have to actually square that 2 first, so that's 4. And then to solve for k, we multiply. Undo that division there. And 24 times 4 is 96. So that's k. Let's put that into our variation equation. So y equals 96 over x squared. Now, constant of variation, okay, found. Variation equation. Okay. And that's all we need to do here.